Hello everyone, we are Team VERTEX from the AeroTech Club of Veer Surendra University of Technology, Burla. We are excited to present our project Ascent, an autonomous aerial exploration and service system designed to operate completely without GPS, external navigation or human intervention. Our system consists of two main components, a UAV and a base station. The UAV performs all sensing, navigation and decision making on board, while the base station is responsible for initialization, validation and charging.
Let's look at the key component used in our drone. S500 quadcopter frame provides a strong, lightweight and stable structure. Emax MT2213 brushless motor with 10 into 4.5 propellers ensuring efficient thrust and stable flight. 40 ampere ESCs provide smooth and reliable motor control. 4S lithium-ion battery enables approximately 13 to 15 minutes of flight time. For control and intelligence, PICSOC 6C flight controller handles stabilization and sensor fusion. Raspberry Pi 5 acts as brain for vision processing and decision making. For sensing and navigation, HoloBro H-Flow optical flow sensor enables precise navigation without GPS. Raspberry Pi high quality camera used for object detection and localization. Additionally, we use Wi-Fi communication for data transfer, AeroTech markers, and docking interference for precise landing and charging.
Now let's understand how our drone operates autonomously. Before the mission begins, the UAV is placed on the base station. In a base station, we have facilitated contact charging. The base station provides 16.8 volt DC power supply and 1 ampere current through a charger which is connected to a power supply of 240 watts. The charger is connected to two oppositely charged steel plates on the base station. The drone has two copper pads attached to its legs, which is again connected to the battery of the drone through a BMS. When the drone's copper plates touch the steel plates in the base station, the charging current is established. The base station sends seed images of target objects to the drone. Once initialized, the UAV performs a system check and takes off autonomously. During flight, the drone continuously captures images using its onboard camera having 12 megapixel and 16 mm telephoto lens mounted on the camera. Using an ORB based feature detection algorithm, it compares live images with stored seed images. When a target is detected, the drone verifies it across multiple frames to avoid false detection. It aligns itself by focusing the object in the camera view and captures a high quality image, also logging its position relative to the base station. For searching, the drone uses a lawn mower coverage pattern. This ensures complete area is covered, no missed regions with efficient scanning. The drone moves in parallel lines, turning at boundaries and continues until the entire arena is covered. Since we are using an M9 GPS which is compatible with PICSOC 6C and having inbuilt safety switch, which we use it only to toggle the safety switch and to observe in which flight state is the drone currently deployed, as the PICSOC 6C doesn't have the indicating lights. Therefore, the GPS is used for the indicator light and safety switch, whereas the actual GPS signal is disabled. Navigation is achieved through optical flow sensor which measures motion relative to ground. IMU, which provides orientation and acceleration sensor fusion using EKF, which estimates position and velocity. This allows the drone to maintain stable flight and track its position relative to the base station. Once the mission is complete, the drone initiates return to base. These steps include navigation back using estimated position, activating vision-based localization, and detecting the base station using visual markers.
For landing, the drone aligns itself using AeroTech markers and computes positional error by applying proportional control to rectify the alignment. Once aligned, it performs a smooth descent landing precisely on the docking station and established electrical contact for charging. After landing, the drone transfers captured images and data to the base station. The base station validates them using ORB feature matching algorithms, and this completes one full autonomous mission cycle.
In summary, our system operates fully autonomously without GPS, uses vision-based detection and navigation. It performs search, detection, return, docking, and supports automated charging with repeated cycle of missions. Thank you for your time. We look forward to presenting Ascent at IRoC 2026. Team AeroTech signing out, fly above and beyond.